Unit 9 Review, Question 1. Determine whether the following describe a one-dimensional, two-dimensional, or three-dimensional measure. So as a quick review, a one-dimensional measure is something like a line. You can move in two directions along this one dimension. Two-dimensional would be something like a sheet of paper. Okay. You can move right and left, but you can also move to the top and the bottom of the paper. And three-dimensional is something like a cube. It's the world we live in is three-dimensional. Okay. So we can go right or left. We could go to the front or back of the cube, and then we can also go up or down. Okay, so in our world, we walk on the two-dimensional ground. If we could fly, there'd be a third dimension, or if you're in a plane where you can go up or down. Okay. So first, the diagonal of a television, and B also talks about a television, so let's draw a television. They're usually rectangular. Okay. Now first, the diagonal. So the diagonal is the distance from one corner of the TV to the other. So notice this is a line, so this is a one-dimensional measure. Now let's look at the screen. I'll use a different color. So the screen is, notice, is two dimensions. It's kind of like a piece of paper. We can go right or left and then to the top or the bottom of the TV. It could also be filled with little squares. You would have to cover it in squares. You couldn't cover it by drawing a line. So that makes it two-dimensional. Let's look at the next one. Actually, the next two talk about the surface of a mug. So let me try to draw a mug. Okay, pretend that's a mug. Now first, the bottom surface of a mug, well, that would be this right here. Okay, and notice it's a circle, it's not a rectangle, but there's still two dimensions for us to move in. We can move to the front and back of the mug and to the right and the left of the mug. Okay, so the ring around the bottom of the mug, that would be one-dimensional. We could draw that with a line. Here, this is two-dimensional. Now, what about the amount of coffee that a mug will hold? So you can imagine filling up this mug with coffee, and it covers the entire bottom of the mug, and then it rises to some point, however much you fill it. So we still have these two dimensions on the bottom, but we also have a third dimension going upwards in the mug. So this would be a three-dimensional measure. Let's look at the next one. Find the length of side L in the figure below. Include units in your answer. So first we'll locate side L. L is labeled right here, and that means from this vertex to this vertex. Okay, the vertex are where the lines meet at a point. Okay, so we want to find this distance, and it's on a grid, and we're told that the side length of one square in a grid is 1 centimeter. Okay. So I'm going to label this as if we were measuring it with a measuring tape. So this would be the starting point, and this would be the ending point for the length. Okay, and each side is 1 centimeter. So from here to here is 1 centimeter, 2 centimeters, 3 centimeters, 4, 5, 6. So the length is 6 centimeters. Okay. Notice it's tempting to count the squares, and sometimes that will work, but notice we're really counting the sides of the squares. The squares themselves are two-dimensional. We're counting the one-dimensional sides of the squares. Sometimes it won't cause you problems. It wouldn't have here, but be careful to measure the sides and not the squares. Question 3. Determine what units would be appropriate to use to measure the following lengths. So we're measuring one-dimensional lengths, and here we have some U.S. customary units and some metric units that we've discussed before. They're labeled in increasing length order, inches are smaller than feet, which are smaller than yards and miles. Millimeters are smaller than centimeters, meters, and kilometers. A millimeter is about the width of a dime. A centimeter is about the width of your pinky nail. A meter is pretty close to a yard, so about 3 feet. And a kilometer, there's 6.2 miles and 6.2 miles and 10 kilometers. So a kilometer is about 60% or 6/10 of a mile. Okay, so if we want to measure the distance from Phoenix to LA, yes, we could measure it in inches, okay, but it would be a lot of inches and so many that it wouldn't really make as much sense to us. So we try to use a unit, that's why it says appropriate measure, that corresponds to what we're measuring. So the largest here is miles, and you're probably aware that that's what we would measure these distances. The corresponding amount for the metric system is kilometers. Okay, they're not equal, but it has a larger length. Now, the height of a textbook. So if you can imagine a textbook, it's about the size of a piece of paper. Okay, you could measure it in feet, but I think it would be a little bit less than a foot, and then it would be fractional. Okay, so a better idea would be to measure it in inches. And in the metric system, for inches, we'll use either centimeters or millimeters, sort of correspond. Remember, this millimeter is a width of a dime. That's really small. Centimeters is about your pinky nail. So I'm going to go with the larger unit here, the centimeter, to measure the book. And now the length of an eyelash, which is very small, okay? We'll use our smallest unit in U.S. customary, which is inches, and also our smallest unit in millimeters. So an eyelash, it might be 1 centimeter, but it's probably smaller. And again, we try to use numbers larger than 1 if we can, so it makes more sense to us. So millimeter. Let's look at the next one. Determine the number of square units shaded in the figure. So this is a two-dimensional object, and we measure two-dimensional objects by the number of squares that fills or covers it. So we want to know this number of squares. Now, there's no formula for what the shape doesn't even have a name as far as I know. So one way we can do this is just by counting the number of squares. So here there's 1, I'll label a few of them, 1, 2, 3, 4, 5, 6. Okay, I'm just going to go across and we can actually label them all, and then we can make sure we don't miss any. 13, 14, 15, 16, 17, 18. Okay, so notice you just want to be careful that you count each square exactly once. It's kind of easy to overlap here. And that you don't miss any squares. And labeling them seems to work. So this ends up being 30 square units. Let's look at the next one. Determine what units would be appropriate to use to measure the following areas. Okay. So when I look at these different measures, I go back to our length units, and basically, so here's a piece of paper. If it's 8 inches by 11 inches, okay, I would, actually, I think it's 11.5 inches, so I just wrote 1/2 inches. Well, you measure its length and its width with inches, so that means you'd measure the inside with square inches. Okay, so if you could think about what you'd measure the length with on any side of the figure, then you want to use the square of that to measure the area. So the land area of Scottsdale, well, you can imagine going from south to north, Scottsdale is miles, so the area would be square miles. Similarly, for a metric unit, we'd use the largest unit here, which is square kilometers. I'm going to use km for the abbreviation for kilometers. Now the surface area of your bedroom, so that's talking about the floor of your bedroom, and usually we measure this in feet. Miles is too big and inches is too small. So my bedroom's about 12 by 14 feet, so I would measure it in square feet. Okay. Now in the metric system we have meters or centimeters. I think centimeters would be too small. There's about 3 feet in a meter approximately. Okay, so I think that would be a good unit of measure. So my bedroom would probably be about 3 by 4 meters, and then we'd measure them to find square meters. And now this should say the surface area of your cell phone screen. You probably know that your cell phone screen is, I think they give you the dimensions in square centimeters. Okay, so we have inches for the U.S. customary unit. Okay, it's shorter than a foot, so we'd want to use inches. Millimeters, again, width of a dime, that's too small. Meters, too big, that's 3 feet, so we want to go with square centimeters.